Hello, Chemistry 11. This is Mr. Chan. And today what I wanted to do was I wanted to go back to something that you folks learned back in grade 10, which was balancing equations. Now, when we talk about balancing equations, what we need to consider is we need to consider the law of conservation of mass. And the reason why we balance equations is that we are trying to satisfy the law of conservation of mass, which basically states that the total mass of reactants must equal the total mass of products, or the number of atoms in a reactants must equal the number of atoms in the products. So basically, the amount that we start off with must be equal to the amount that we end off with. That's the law of conservation of mass. Now, this law will hold true in a closed container because no reactants or products are allowed to escape. Now, what is a closed container? A closed container is basically something that is sealed. Container. Okay. So an unopened pop bottle would be considered a closed container, or it is sealed because nothing can escape and nothing can come in. Now, an equation can be written to describe what happens in a chemical reactions. Now, on page 132 in your Heath chemistry text, what you will see is a little table like this. Okay, and this table sort of gives you all the sort of information that we commonly use in chemical reactions or chemical equations. Now, one thing that I would like you to be aware of is notice the phase symbols, S, L, G, and AQ. Now, most of you are familiar with S, L, and G, which is solid, liquid, and gas. But probably AQ, some of you haven't seen before, which AQ means aqueous. And what that means is the substance is dissolved in water. Now, sometimes a lot of people get confused between what is a liquid versus AQ. Okay, and what I want to do is just show you a quick do a little bit of quick explanation of the difference between the two. So let's say, for example, we have sugar. Now, sugar is C6H12O6. If we put an L behind it, what that means is that it is melted. Okay, so what that is you put it onto a stove, you turn on the stove, you put some sugar in there into a pan, and what happens is you let it melt. Now, what is C6H12O6? If I put AQ, what that means is that it is dissolved in water. So what you do is, let's say you make tea in the morning or coffee in the morning, and when you put sugar into your coffee or tea, what happens is that because it becomes dissolved, that's why we put the AQ behind it. So please make sure you are aware of the difference between L and AQ and what they mean. Okay. Now, another one that you should be aware of is when you have a subscript and when you have a coefficient. Okay. Now, and I've put that in my notes saying that the coefficients give us the relationship between reactants and products, basically how much reactants we have and how much products we have, while the subscript gives us the number of atoms of that particular element in the compound. For example, H2O. All right. So for H2O, if I were to write it down, H2O, the two basically means that there's two hydrogens in this particular molecule. Now, when balancing equations, one can use a variety of methods, trial and error or algebraic. Now, you folks probably did the trial and error, or your teachers might have said guess and check back in grade 10. Now, nothing wrong with that particular method, but it's very good for simple equations, but the algebraic is actually better for more complex equations. Now, no matter what method you choose, here are a couple of hints. If you see an element by itself, not bonded to anything, leave it last to balance. And if you see the same polyatomic ion on both sides of the equation, you keep them together when balancing. All right. Now, let me give you, a few quick examples here. Okay. So the first one I want to give you is one that some of you probably are familiar with from back in grade 10. So let's say example number 1. So let's say we have H2 and Cl2 gives you HCl. Now, depending on your teacher might say, okay, you draw this, you have 2 hydrogens, you have 2 chlorines, and in this case, you have a hydrogen and chlorine. Now, you check your reactants, you check your products, you say, hey, I don't have enough hydrogen, I don't have enough chlorines, so you add another HCl, everything is balanced, and then you go, I just put a 2 in front of HCl because I drew 2 of them. Now, that is perfectly fine. That's what we call the trial and error method or guess and check that you probably did back in grade 10. Now, what is the algebraic method? So I'm going to use a different color here so you can see. All right. Now, back in grade 10, you folks probably did something like this, where you had C3H8 plus O2, whoopsie, gives you CO2 and H2O. Now, some of you might have found that a little bit more complex. Okay. Now, so how do you do the algebraic method? So for the algebraic method, the setup is the key. So I will give each reactant and product a letter. So this will be A, this will be B, this will be C, and this will be D. Now, what I do is I look for the elements that are in this particular reaction. So in this case, I have carbon, hydrogen, and oxygen. Now, what I will do now is look for each element under the letters A, B, C, and D. So if I look at the reactants, for carbon, notice it is under the reactant A, and there's 3 of them. So I go 3A. Oxygen is 2B. Oh, sorry. Hydrogen is 8A, and oxygen is 2B. Now, I put the equal sign because remember, reactants are equal to products. So in this case, I look at my products. Carbon is 1C, hydrogen is 2D, and oxygen, you notice, is in carbon dioxide and water, 2 different substances in the products. So I just add them up. So 2C plus 1D. Now, what I do next is I set it up as A, B, C, and D. And what I'm going to do is I'm going to choose one letter, A, B, C, or D, and set it as 1. So in this case, I'm going to choose A is equal to 1. Why? Is because if I look back at the equations that I set up, notice A is part of a lot of the simple equations. So if I look at this equation, and if I set A is equal to 1, I look at the first equation. So I have 3A is equal to 1C. If A is equal to 1, so it's 3 times 1 is equal to 1C. I divide both sides by 1. So 3 is equal to C. So C is equal to 3. Now I look at my second equation. 8A is equal to 2D. If I know A is equal to 1, so 8 times 1 is equal to 2D. Divide both sides by 2 to cancel out the 2's. And so what I get is 4 is equal to D. So D is equal to 4. Now, I look at my third equation. I have 2B is equal to 2C plus 1D. Now, here, so I have 2B. I know what C is. C is 3, so 2 times 3 plus 1 times D, which is 4. I divide both sides by 2, cancel out. And what I get is an answer of B is equal to 5. So B is equal to 5. Now, what do I do with the numbers 1, 5, 3, and 4? So this would be 1, 5, 3, and 4. That's it. Now, this one does work well with more complex equations. Now, back in grade 10, you probably did the guess and check method. But in this case, I find that that's a little bit easier, especially for more complex. Okay. Now, I want to touch upon this. It says, if you see the same polyatomic ion on both sides, keep them together. Now, how would I do that with the algebraic method? So let me give you a fairly simple, straightforward one. So I'm just going to draw a line here to illustrate the idea of a polyatomic. So let's say, for example, here, let's say if I had CuSO4 plus Fe gives you Fe2 SO4 brackets 3 and Cu. Now, if we were to set it up just like here, where I identify the different substances in the reaction, here I would go, okay, Cu, but notice I have the polyatomic of sulfate on both the reactants and the products. So because I see it on both the reactants and the products, I go SO4 and then Fe. Okay, and then the setup is exactly the same. You have A, B, C, and D. So this would be 1A. SO4 would also be 1A because I have 1 SO4s. And Fe would be 1B. If I look at my products, copper is 1D. SO4 would be 3C. And then Fe would be 2C. Now you have A, B, C, and D. Now, again, you can choose whatever one you want. So in this case, let's say if I chose, I don't know, I'm going to choose C as equal to 1. If I chose C is equal to 1, A, using the equation like what we did up here, A would be equal to, oh, let's do it here. So 1A is equal to 3C. 1A is equal to 3 times 1. So A would be equal to 3. Notice it's the same math calculations. Here, A is equal to 3. If I look up here, 1A is equal to 1D. So if A is equal to 3, D is equal to 3. Okay. And if I look at the last equation, 1B is equal to 2C. If C is equal to 1, B is equal to 2. And so all you do now is you just write 3, 2, 1, 3. Now, some of you might say, well, Mr. Chan, what if I did D is equal, let's say A is equal to 1. I'll put it in a different color. If A is equal to 1, then D is equal to 1, C is equal to 1/3, and B would be 2/3. That's if you had set A is equal to 1. Now, because you have fractions, what you can do, remember back in grade 10, is you multiply, in this case, by 3 to get rid of all the fractions. So you have 3, 2, 1, 3. So you notice you get the exact same numbers, it's just a little bit more work. So that's just to prove to you that doesn't matter what letter A, B, C, or D you use, you will get the exact same coefficients. All right, folks, thank you very much. Have a good day. Bye-bye.